Welcome to the course on Python for Data Analytics, Machine Learning and Generative AI. In this video, we are going to learn about control flow in Python, specifically loops and conditional statements. Control flow tells us how a program runs. In this video, we will cover what is control flow, the if statement, elif and else statement, how to write concise conditionals. Then we will also see for and while loops and the range function and how to gain precision control over loops and end with break, continue and pass statements. Control flow refers to the order in which a program statements are executed. By default, Python executes code line by line from top to bottom. This is called the default flow of a program. But real-world programs cannot work only in a straight line. They need a make decision, repeat actions and change direction. That is where control flow statements come into play. Control flows allows a program to make decisions, which means certain blocks of code will run only when specific conditions are met. For example, checking whether a student has passed an exam or whether a user is eligible to log in. In Python, this is handled using if, elif and else statements. Control flows also helps us repeat action efficiently. Instead of writing the same code again and again, we use loops to perform repetitive tasks. This is useful when processing lists, working with datasets, or performing calculations multiple times. Python provides for loops and while loops for this purpose. In addition, control flow allows the program to change its execution path based on new information. Statements like break, continue and pass help control how loops behave, when they should stop or when certain steps should be skipped. Mastering control flows transforms static scripts into dynamic and responsive applications. It is the difference between a simple calculator and an intelligent system that can decide, repeat and adapt. Now let's understand the foundation of logic in Python, which is the if statement. The if statement is used to make decisions in a program. It executes a block of code only when a given condition evaluates to true. This is the simplest and most important way to introduce decision making into your program. Let's first understand why we need the if statement. We make decisions all the time. Let's see the example of eligible to vote. In Python programming, we want certain code to run only when a condition is satisfied. Here, we have a variable called age and its value is set to 20. We use the if statement to check a condition age greater than or equal to 18. If this condition is true, Python executes the indented line below it, which prints eligible to vote. If the condition is false, Python simply skips that block of code and moves on. This brings us to the important concept of indentation. In Python, indentation is mandatory. Indentation is the space left at the beginning of the line or a paragraph pushing text away from the margin. In Python, indentation defines which statements belong to if block. Only the indented code runs when the condition is true. Now, look at the flowchart. The diamond shape represents the condition, check. Is age greater than or equal to 18? If the condition is true, the flow moves to the print statement. If the condition is false, the program skips the print statement and continues execution. Finally, the output shown at the bottom confirms that since the age is 20, the condition is true and the program prints eligible to vote. Now that we understand the if statement, let's move one step further and see how Python helps us handle every possible situation using elif and else. We usually don't have just one condition. We often need to check multiple conditions one after another. This is exactly where elif comes in. The else statement provides a default block of code that runs when none of the if or elif conditions are true. So instead of leaving a situation unhandled, else ensures that something always happens. The elif, which stands for else if, allows us to check multiple conditions sequentially. Python checks each condition from top to bottom, and as soon as one condition becomes true, its block of code is executed and the rest are skipped. Now let's look at the code. Here the variable x is assigned the value 42. The program first checks the condition x less than 0. Since 42 is not less than 0, this condition is false and Python moves to the next one. Next, it checks x is equal to 0. Again, this is false. Then it checks x is equal to 1. This condition is also false. Since none of the above conditions are satisfied, Python executes the else block, which prints more. An important thing to remember is that in an if, elif, else structure, only one block of code is executed. Conditions are checked in order, and once a condition is true, the rest are ignored. An if, elif, else sequence provides a clear, readable, and efficient way to handle mutually exclusive conditions. The situations where only one outcome can be true at a time. Python allows us to write clean and concise conditional statements, often referred to as the Pythonic way of writing code. Python emphasizes readability and simplicity, and for simple conditions, we don't always need long blocks of code. Let's start with concept 1, the shorthand if statement. When an if statement contains only one line of action, Python allows us to write the condition and the action on the same line. In the example shown, the program checks whether the age is greater than 18. If the condition is true, it immediately prints eligible to vote. This approach is useful for simple, single-line operations, and it helps keep the code short and readable. Now, let's move to the concept 2, the shorthand if-else statement, also known as the ternary operator. The ternary operator allows us to assign one of two values to a variable based on a condition, all in a single line. In the example, the variable mark is set to 45. The program checks whether the marks are greater than or equal to 40. If the condition is true, the result is assigned as pass. If the condition is false, the result becomes fail. Finally, the result is printed, and since the marks are 45, the output displayed is result pass. While these shorthand conditionals are powerful and elegant, it is important to use them wisely. As highlighted, these approaches are best suited for simple and clear conditions. When logic becomes complex, using the full if, elif, else structure improves readability and maintainability. Now let's talk about one of the most powerful concepts in programming, loops. Loops allow us to execute a block of code repeatedly, saving time and making our programs efficient. Python mainly provides us with two types of loops, the for loop and the while loop. Let's begin with the for loop. The for loop is used to iterate over a sequence of items such as a list, a string, or a range of numbers. We use a for loop when we already know what collection we are working with and we wanted to perform an action for every item in that collection. For example, printing each element in a list or processing each value in a data set. Now let's look at the while loop. A while loop executes a block of code as long as a given condition remains true. Unlike the for loop, we may not always know how many times the loop will run. We use a while loop when we know the condition that should stop the loop, but not the exact number of repetitions. For example, repeating an action until a user enters the correct input or until a certain value is reached. So, use a for loop when you have a known collection and need to work on each item. Use a while loop when repetition depends on a condition. Both loops are essential tools and are widely used in real-world programs, data processing, and automation. Now let's take a closer look at one of the most commonly used loops in Python, the for loop. The main purpose of a for loop is to iterate over the items of a sequence. A sequence can be a list, tuple, string, set, or even a dictionary. The for loop processes items one by one in the order in which they appear. Let's understand this with the example. Here we have a list of words: cat, window, and defenestrate. The for loop takes each word from the list, one at a time, and assign it to the variable w. Inside the loop, the program prints the word along with its length using length of function. So, for the word cat, the length printed is 3. For windows, the length is 6. And for defenestrate, the length is 12. That's exactly what we see in the output. This example clearly shows how the for loop allows us to perform the same operation on every item in a collection. One of the biggest strengths for the for loop is that it is very versatile. We can use it to iterate over characters in a string, iterate over items in a list, iterate over keys in a dictionary. By default, whenever you have a collection of items and you want to perform an action on each item, the for loop is the most precise and readable choice. Now let's understand the second type of loop in Python, the while loop. The while loop is used when we want to repeat a block of code as long as condition remains true. The moment the condition becomes false, the loop stops automatically. This makes the while loop very useful when we do not know in advance how many times a task needs to be repeated. Let's look at the code. Here, we start to initializing a variable called cnt, which is count, with the value 0. The variable is used to control the loop. The while condition checks whether C and T is less than 3. As long as this condition is true, the code inside the loop is executed. Inside the loop, the program prints hello geek. Then the value of count is increased by 1. This step is very important because it eventually makes a condition false. As a result, the loop runs exactly 3 times and we see hello geek printed 3 times in the output. Now let's talk about the infinite loop. If the condition in a while loop never becomes false, the loop will run forever. For example, a loop written as while true will never stop on its own. Infinite loops can be useful in some applications such as servers or game loops, but they must always include an explicit break statement to exit the loop safely. So, a while loop repeats based on a condition. It stops when the condition becomes false. Proper update of the condition is essential to avoid infinite loops. Now let's look at a very important and commonly used function in Python loops, the range of function. Whenever we need to iterate over a sequence of numbers, the range of function is the standard and more efficient tool to use. Let's go through the most common patterns of using range. The first form of range of end. Here, Python generates numbers starting from 0 up to but not including the end value. For example, range of 5 produces the value 0, 1, 2, 3 and 4, which is exactly what we see in the output shown on the slide. The second form of range is range of start comma end. In this case, Python starts from the given start value and goes up to but does not include the end value. For example, range of 5 comma 10 generates values 5, 6, 7, 8 and 9. The third form is range of start comma end comma step. Here, Python generates numbers starting from the start value, increasing by the given step size each time until it reaches the end value. For example, range of 0, 10, 3 produces 0, 3, 6 and 9. The visual diagrams on the right side of the slide clearly shows how Python moves from one value to the next based on the parameters provided. While you can combine range of with length of to loop through index positions, Python provides a more readable and Pythonic option called enumerate, which gives you both the index and the value at the same time. So, the range of function is simple to use, memory efficient, perfect for numeric loops. So far, we have seen how loops run from start to finish in a fixed sequence. But in real program, we often need more control over and how a loop behaves. Sometimes you may want to exit a loop early, skip a specific iteration, or simply do nothing for a certain condition. To handle the situations, Python provides loop control statements. Let's start with the break statement. The break statement is used to exit the loop entirely even if the loop condition is still true. Once break is executed, the loop stops immediately and the program continues with the next statement after the loop. In the diagram shown, the loop stops at step 3 because a break statement is encountered. The continue statement does not stop the loop. Instead, it skips the rest of the current iteration and moves directly to the next iteration. In the diagram, when the loop reaches step 5, The continue statement causes the program to jump ahead, skipping the remaining code for the step and continuing with the next value. The pass statement does nothing at all. It is used as a placeholder. When a statement is required synthetically but no action is needed yet. This is useful during development when you want to write the structure of the code first and fill in the logic later. So, we can tell break exits the loop completely. Continue skips the current iteration. Pass does nothing and acts as a placeholder. Using these statements gives you precision control over loops, making your programs more flexible and efficient.